Okay, we're going to study some proportionality theorems here that deal with some triangles. So here's the first theorem. It says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So basically what it's saying is that you have to know that you have two parallel sides. So remember, this is what these markings mean right here. So these lines are parallel, okay? If they're parallel, then they are going to cut the sides into proportion. So this segment right here is in proportion to this one. And then on the other side, this segment is in proportion to that one. Okay, so that's our proportionality theorem. So let's go ahead and try a couple problems. So this one tells you that QS is parallel to UT. So I know that they're parallel, so I know we're supposed to find the length of RQ, so I'll just put my X here. I know that this piece right here is in proportion to this piece, so I'm just going to say X over 9 equals, and I'm going to do the other side, 4 over 6. And then if you go ahead and solve that, you get 6x equals 36. So x equals 6. Okay. Another one. So QS is parallel to UT. So I want to figure out what UT is. So we're going to go ahead and this one, now remember the theorem says that it bisects this piece is proportional to this piece, and this piece is proportional to this piece. Okay, UT is not in those sides. So what I'm going to do instead, I'm not going to use that theorem, I'm going to use one that we used in last time's lesson. I'm going to split these triangles into a smaller triangle and a bigger triangle. And so this is RQS, and this is RUT. So this side right here is 6, and QR is 4. Now RU is 14 plus 4, so that's 18, and UT is the one that I don't know. That's X. Now these triangles are similar, so I can do a proportional between them. How do I know they're similar? From our lesson last time, angle-angle similarity. This angle right here is congruent to this angle. These lines are parallel, so those are corresponding angles. And then they both have angle R in them, which is reflexive property. So I know the two triangles are similar, so I'm just going to write a proportion based on that. So I'm going to compare corresponding sides. So 4 is going to match up with 18. Whoops, wrong letter here. So 4 matches 18, that side, equals 6 over x. And then I'm just going to go ahead and solve that for x. So 4x equals 18 times 6, which is 108, and then I'm going to divide that by 4. 27. Okay, so just because they tell you that you have parallel lines right here, you got to make sure of what pieces you're talking about, because the theorem is only talking about certain pieces are proportional. So you got to make sure that you're matching that up. Okay, here's another one. Find the value of x and y. So looks like to me, because of these markings right here, I've got parallel lines. So I know that this side right here is in proportion to the 9. And so I could say 12 over 9 is equal to, and it's in proportion with this piece right here and this piece. So x plus 5 over x. So I'll go ahead and multiply that out and get my answer. So 12x equals 9x plus 45. Subtract our 9, so 3x equals 45. So x equals 15. Okay, so to do y, I'm going to separate the triangles because y is a part of, it's not part of the proportional proportionality theorem that we learned today. Just going to go back to the similar triangle rules from last time. So I'm going to draw two triangles. I'm going to draw this green triangle right here. So let's make a sketch of that one. So here's the green one. And this side is y, this is x plus 5, which I now know x is 15, so that must mean this side is now 20, if I want to use that, and 12. Okay, and that's going to be in proportion. I'm going to do the big blue triangle. So big blue triangle is going to be this side right here is 30, and then remember, x is 15, so this is 20 plus 15. So this whole side right here is 35. And then the bottom is 9 plus 12, which is 21. Okay, so now you just have to pick corresponding sides. I for sure have to pick the y because that's what I'm looking for. So I'm going to say y over 30 equals, and then I'll just pick the smaller numbers, 12 over 21. And then we'll figure out what that answer is. So 21y equals 12 times 30. And then we're going to divide that by 21. So y is about 17.14 units. Okay, so same picture again. So we're trying to figure out what Wx is. So Wx is on the outside here, so I think I'm going to use that proportionality theorem. So I'm going to compare x squared is proportional to 4, and x plus 3 is proportional to 1. Okay, so that means then that we have x squared equals 4x plus 12. Now remember, this is quadratic, so in order to solve a quadratic, you're either going to have to factor it, put in the quadratic formula, or complete the square. I prefer factoring or quadratic formula, so I'm going to put it equal to 0, and we'll see if it'll factor. And if it'll factor, I'll do that. If not, I'm going to put it in the quadratic formula. So factor pairs of 12, I think I will use 2 and 6. Looks like to me it'll factor. So I'm going to go x minus 6, x plus 2 equals 0. So x equals 6 and x equals negative 2. Okay, if I put negative 2 back into my problem, let's see if that works. So if I put negative 2 back in, negative 2 plus 3 is 1. So that side would be 1, and a negative 2 squared is 4. So that looks like that could be an answer. So we want to find the length of Wx. So Wx could equal 4 when x equals negative 2. And when x equals 6, let's figure out what our answer will be then. So let's put a 6 in. So Wx, 6 squared would be 36. So it would be 36 when x is 6. So if it's 36, probably not, it's not exactly drawn to scale for either one, but anyway, that's what it would look like. So both answers work. You could have 6 or negative 2. It's okay to get a negative x. It's just not okay to get a negative side length when you substitute x back in when you're solving the problem. Okay, now the converse says this. If you know that these two are proportional, so if I know that RT is proportional to QT, and then on the other side, UR is proportional to SU, then I can say that these two lines are parallel. Okay? So just because they look parallel doesn't mean they are. You have to show that those two pieces are in proportion, those 4 pieces, I guess, 2 sets. If you can prove that, then you know the lines are parallel. So this one says determine whether BC is parallel to DE from the given proportions. Okay, so let's see what we know from this one right here, AB. So AB is this piece, it's proportional to BD, and AC is in proportion to CE. So that's true. We can say that BC is parallel to DE. Okay, let's try it again. I'll erase those colors. AC is this side right here, is proportional to CE, and BC is proportional to DE. Okay, that's a no. That one, I don't know that that's given, if I don't know that they're necessarily parallel from that. So that one is, don't know. BC, I don't know that it's necessarily parallel to DE. If I had the whole length of AE, then I could probably do it. But because I have just this piece could correspond with this one, but in the big triangle, this side is supposed to correspond to this one, and it gave me this little piece instead. So we don't know that those are parallel. We can't use that proportion. That proportion's not true. Okay, last one. So BD is this piece right here, and proportional to CE, this side over here, okay. And then AB is proportional to AC. Okay, that's true. BC is parallel to DE. When you're working with proportions, anything that's on the diagonal should be equal. So if you were going to look at question number 1 and number 3, this diagonal right here has segment A, B, and CE. Notice on the bottom one, they're still on the same diagonal. They're just in different spots. They can switch places, and the same thing with AC and BD. If you multiply the two diagonals together, then you should always get the same two things equal to each other. So they can kind of switch places on the diagonals. That's a true property. Okay, this one's next one, new theorem. If there 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So here's our parallel lines. This is marking parallel right here, this symbol right here. So we've got these 3 parallel lines. So it is marking things in proportion. So basically what they're saying is that A and B are proportional, and X and Y. I kind of like this one just because it looks like it kind of sets up the fraction already. See, look how AB is proportional to AB, and XY is proportional to XY. It kind of sets that proportion up. So it says write 3 other proportions that would be true. Well, we just talked about on the other slide how we can move things around on our proportions. We could look at our picture, or we could just take our proportion and move the diagonals. So I could say A over X equals B over Y. That's true. So if you come over here to your picture and compare, you'd be going left to right. A to X is proportional to B to Y. That's true. That matches. Let's do another one. So I'll go back to the original, and this time I will switch this diagonal. I'll switch these two. So that's going to say Y over B equals, let's see, what are we switching? Y over B equals X over A. Is that true? Yeah. Remember what I said, that if you multiply the diagonals, they should be equal. Look on the one on the left. A times Y is AY equals B times X, which is BX. Do we get the same thing over here when we multiply the diagonals? A times Y equals B times X. Yes. Okay, so we need to come up with one other one. I think I'll just flip both. I'll do the reciprocals of both parts. So for the last one, I'm going to do B over A equals Y over X. And you can look at that, and let's just see if we multiply that out. What do we get? AY still equals bx if you multiply the diagonals. So those are all true proportions. Those are three other proportions that would work. Okay, this says find the value of x. So when I'm looking at that, I kind of see fractions already. I see here and here and a fraction bar right in the middle. So I'm just going to write my proportion as x over 6 equals 8 over 14. Solve that. So 14x equals 48. So x equals 48 divided by 14. Oops, just a minute. 48 divided by 14, 3.43 about. So x is about 3.43. Okay, new theorem. This one's called the triangle angle bisector theorem. So an angle bisector of a triangle will divide the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So the angle bisector in this picture right here is this line right here. It's bisecting this angle right here. So those two little red arcs mean that each side is equal, each of those angles. So that means it's an angle bisector. So if you end up with that, then what you can say is that A is proportional to B and X is proportional to Y. So that one I went left to right. It says write another proportion. So if I were looking at the picture, I think I'll just write this one up and down. I'll just say A over X equals B over Y. Let's just check and see if that really is true. If I were to multiply the diagonals, I'd get AY equals BX. Is that what I get on the top, the blue letters? If I multiply them out, I get AY equals BX. So yep, those are true proportions. If you multiply the diagonals, no matter how you write it, they should equal the same thing. Okay, so find the value of x. So because this is marked right here as an angle bisector, I know I have some things that are in proportion. So I'm going to say 21 over 15 equals 14 over x. So 21x equals, and 14 times 15 is 210 divided by 21, so x is 10. So this piece right here is 10. Okay, last one. Once again, I've got the angle bisector marked. This angle is congruent to that one, so this is my angle bisector. So basically I can say then that 14 matches, so 14 is in proportion to x, so I'm going to go 14 over x equals, and I'm going to do the other side, 11 over, what's that number right there? Well, I don't know. I know the whole thing's 20, and I know the other side's x, so this must be then 20 minus x. So 20 minus x, okay, let's go ahead and multiply that out. So 11x equals 14 times 20 minus 14x. Combine your like terms, so that's going to be 25x equals 280. So x is going to equal 11.2. Okay, I think we're done.